All right. Welcome everybody. I am Mike Freeman, and I am delighted to be joined today by Harry Stevens from the Washington Post. And we are going to walk through how to build a simulation that I remember seeing last March and being really impacted by the way that I thought about COVID and anticipating what was to come. So, Harry, do you want to tell us a little bit about yourself and a little bit about how this project came to be?
Yep. Thanks, Mike. It's awesome that everybody's here. Really excited to be here too. I've been looking forward to this for a long time. I'm Harry Stevens. I'm a graphics reporter at the Washington Post, which means I do sort of a bit of what might be thought of as traditional journalism sort of activities, but I also make graphics, charts, maps, animations, simulations, things like that. I try to get people to engage with the news and current events in ways that are, harder to do with text alone, and, sort of taking advantage of the fact that the internet is the dynamic medium and you could do cool stuff with it. So today, I'm going to show how to make a sort of toy disease simulator. As you saw in this article, so it had like these sort of bouncing circle simulations where the circles bounce off of each other and they make each other sick, and then eventually they become immune, or they recover from the disease and they become immune. And yeah, I mean, I just want to be clear. Very clear that this is a toy disease simulator, so you can't use it to like make predictions about real diseases or anything like that. There are computational epidemiologists out there in the world who do try to create simulations that will predict actual diseases, but this is not one of them. This is those are computationally much more intensive and factor in a lot more things about the real world. But so this is more of just to be a visualization to give people a kind of mental model of how to think about how things can spread through a network. And also, before I go any further, I should just disclose. So I work for the Post. I'm also an Observable ambassador. So that just means it's not a paid position, but it means that I and other ambassadors sort of get to like test out certain features earlier and give feedback on them. But mostly it's just because I use the product a lot and I really like it. And so, I'm a friend of Observable, or I try to be. And so that's what makes me an ambassador. After I sort of introduce the basic mechanics of this thing, then, you can sort of tweak the parameters. This really tries to show how, one person's activity in one part of this simulation can end up affecting other people with whom they have no interaction at all, which is sort of the key insight to, explaining network effects, and that there's this kind of exponential growth curve until people start recovering. And then, so that let me then like mess around with the simulation a little bit by changing how it works, like putting a wall in between to represent like a quarantine. But then like just to show that quarantines are kind of hard to enforce and they tend to break. And so, you might have an outbreak anyway. So that's what this one was showing. And, then I, did a thing where trying to show how social distancing might work, within the context of the simulation, by just like not letting some of them move. I think this, makes it so that a quarter of the population moves and the other 3/4 just like stops moving. And it really disrupts the network. So it was trying to, social distancing at the time was kind of a new concept. So it was sort of showing how that might work. And then like even more social distancing. So now, only an eighth of the little guys can move. I mean, it ended up being a pretty, I think a surprisingly useful way to think about how some of this stuff might work. So the audience responded really positively to it. Not just lay people, but also sort of epidemiologists or scientific communicators who are trying to explain some of these ideas. because yeah, I mean, I think sometimes science communication is really difficult, and so if you can kind of give people something to like some visual to reference in their minds when they're thinking about a concept, even if that visual is not like perfectly accurate, if it's sort of like close enough to describing reality, then yeah, it can really help people think about these concepts. And then at the end, the purpose of data visualization is comparison. So I showed all 4 of them. One of the things that I try to be really careful with, and I mentioned this earlier, is that yeah, you just don't want to overstate what this is showing. So I made it clear it's called Simulitis. It's not COVID-19. But that it does show network effects.
Yeah, I mean, I think that this, even watching it again, there's such clear encodings of things like the ripple effect that people's actions have on one another, and these ideas of what something like quarantine can do. I'm wondering what gave you this structure to think about disease transmission? Like, how did you go from all of the information that you were trying to parse to this 2-dimensional box where you have balls bouncing off of each other?
Yeah. So this was kind of lucky that I'd kind of been messing around with these before, like way before COVID. So this was the first time I ever did a bouncing ball thing. And I don't know if the blocks.org was sort of Observable's predecessor. And so this was like, I was just trying to make these circles bounce off the wall. So it's just kind of like a coding experiment, trying to learn a little bit about geometry and, like changing something, how that might change what happens inside of the simulation. And you could see actually how like somebody who was doing this kind of stuff already, and then Observable came out, it would be like, oh, this is awesome. Like, it really spoke to me. And then, yeah, I mean, I kept working on it over the years. So this was like getting them to bounce off of each other. And so this is what we're going to do today. And then like actually more recently, I like used a quad tree. It's like a spatial index, so that you're only comparing circles to circles that are near them rather than to every other circle. And it's a bit more efficient, although I'm sure that if I were, better at coding or whatever, I could get this to go faster. But
well, Harry, when you said that we should build this up from scratch in an hour, I thought that was ambitious. And then you proved to me the other night that we could work together and do that. And I think that is what I think a lot of folks are here excited to see. We've got some great context, got an exciting tool. Like, let's see how we can go ahead and build this.
Awesome. Yeah, let's do it. So yeah, should I just get started?
Yeah, we are working out of this notebook that I just put a link to. And we will periodically republish these changes as we move. But Harry and I are going to be working together in this notebook, by which I mean Harry will be working diligently, and I will occasionally comment on his code to help make it clear. And we'll keep an eye on the chat, answer some questions, and let's dive in.
All right, cool. So we're just going to start out by making a new class, which will let us implement the simulation. And it has a constructor, which will take some options. So the first thing that we need is width and height. So I know that you can do this with object assign, but I always forget how. So we're just going to say, like, if somebody passes options with a width, then we're going to use that. But otherwise, we'll just use the notebook's width. This width, if you haven't used Observable, this width, it's just like comes with the cell. And it's like whatever this width is. And then for height, we'll do like a similar kind of deal. But we will set the default height to like 500. And we're going to return this. And actually, for all the methods within our class, we're going to return this, and it'll make method chaining possible. So yeah, so now we're just going to make a new simulation using this Simulitis class. So we don't do const in Observable. New Simulitis. return simulation. Oops, what did I do? Return simulation. Now we have a simulation. It's got a width and a height. If I pass my own height, I change this height. But we'll use our default height. And yeah, I mean, what's nice about this now is that you could use it in another notebook. So, you know, you can say like import Simulitis from this. Could use it somewhere else. So let's see how this works. Let's try to visualize it. So making a canvas. We're going to use Canvas instead of SVG because Canvas is going to render a little bit smoother when we're doing a lot of calculations. I'm not as familiar with the Canvas API. I think SVG is a little bit easy to remember. But yeah, for this case, we are going to use Canvas. So let's see, DOM canvas, simulation width, simulation height, and return the canvas node. Oops, it's not a function. What am I doing wrong here? Let's see. Canvas, return, oh, we just returned canvas, not a function. What am I doing? Yeah, so there we go. We have a box, and we're just going to give it a border.
And something that I really like about the way that you've structured this already is that you have the computation of the simulation happening in one place and then the visual rendering of it in another place. So if you wanted to do some other rendering, you could choose to do that as well.
Yeah, totally. It's agnostic about how you want to show it. Okay, so let's go ahead and make our first method, which in this case is going to be a method to add a person to the simulation. So we'll make a default radius. Why don't I just call that radius? And oh, we're going to need like an empty array to push people into. Why don't we call it people? Here's an empty array called people. And so I'm going to do this people push. Oh, you know, this is where I can use object assign. Object assign. And so I'll pass whatever the user passes as a person will take precedence over these defaults. So here's a default radius, position. So if you're just thinking about like what we need to know about each person in the simulation, we need a position with an X and Y coordinate. So X is going to be it's going to be a 2-item array. X is going to be the first number and Y is going to be the second number. So in other words, X will be the 0 index and Y will be the 1 index. And we can use D3 random uniform to just like do a number between, you know, it'll return a random number between a low bound and a high bound. And right, so this case, since we already have the radius, so we want to think about for the X coordinate, like what's the leftmost we would allow the position to be, and that'll be the radius times 2. So it just starts within the bounds of the simulation, and then this width minus radius times 2. And then, so the cool thing about these D3 random functions is you can actually make like a random seed, and then as it generates additional numbers that all follow a distribution. But since this is a random uniform distribution, it really doesn't matter like whether you use a seed or you just kind of call the function each time. So, but if you ever use D3 random to make like different types of distributions, you can take advantage.
All right. So we've got a class that defines how the simulation works. You instantiate it, and it now has this new method where you can add a new person to that simulation, and the information that you're keeping track of is how big they are, their radius, where they are in 2-dimensional space, their position. You've given them a speed, they're headed somewhere, they're on the move, and you're keeping track of where they're moving with this last argument that you called angle.
Right, exactly. And yeah, I mean, I think that I also want to be clear here that like what I'm doing today is just how I did it. I'm sure that there are better ways, but I think maybe part of the educational value of this is just to show that like you can kind of, thanks, Mike. You can kind of like logic your way through some problem like this that you've never done before and don't really know how to do. So now that we have a method to add a person, also I'm returning this again for method chaining purposes. We are going to add some folks to the simulation. So we're going to say like for let I equals 0, I is less than 200, I plus plus. We're going to add 200 people to the simulation. Simulation add. And again, like we could pass specific properties, but I think that we're going to be happy for the time being, at least, with just these just these defaults. And so yeah, now I have an array of people. Each person has a radius, a random position, speed 1, and a random angle. And so yeah, we're going to draw them all. So we again are going to need a for loop. So we can say like for let I equals 0, L equals simulation. Simulation dot data dot length. I is less than L. I plus plus. Const person equals simulation. I don't know why that keeps happening. Simulation dot data I. And yeah, so we're going to need a context in order to draw stuff to our canvas. So const context equals canvas get context 2D. And yeah, so the way to draw circles in Canvas is to use this arc function. So we're going to do context begin path, and then we're going to use the arc function. And the arc function, it takes, let me think, 1, 2, 3, 4, 5 arguments.
It's so hard just to draw a circle.
I know, right?
It's 2021. It's so hard to draw a circle on the internet.
So we're going to use destructuring of the array for the first 2 arguments. Remember that each position is just a 2-item array. And so we're going to pass like the X position and then the Y position. These 3 dots destructure that. So you pass one number and then the other number for the first 2 arguments. Then we're going to pass the radius. And then the last 2 arguments of the arc function are the start angle and both of these are in radians. So start angle in radians, the end angle in radians. So 2 pi radians is a full way around the circle. And then we're going to fill it. And I unfortunately broke it. Simulation people, nice. Yes. So now we have all of our nodes in the system, and we need to get them moving. Also, something I'm going to do is I'm going to make a convenience function called each. So rather than writing this for loop, I can make a convenience function in the Simulitis class. So it's going to be called each, and that's going to take a function. So I guess I'll just call it fn, and we can do for let I equals 0, L equals this people length, I is less than L, I plus plus. And then we're going to run the function on this people I, and then we'll also like let the person access the index and the whole array, just kind of how these things tend to work. And yeah, I guess I can return this. I don't see any harm in that. And then so now instead of this whole thing, I can just write simulation each person. All right, find person. I think that'll still work. No, what did I do wrong? Oh, yeah, that's not how you write JavaScript. Okay, so that's a nice little convenience function to have. And yeah, so how do we get them moving? So in more like traditional browser environment, you're going to use an animation frame, like request animation frame. But in Observable, like I guess the runtime continues to reevaluate. And so we can just write while true and yield the canvas. And then we can, on each tick, we can draw the person. As you see, like, see how these are getting really, really thick? That's because the canvas continues to render on top of itself without erasing itself. And so what we have to do is do context clear rect on each tick. And clear rect takes 4 arguments, the top left and the bottom right. So simulation. Thanks. And so now it's just going to keep rendering on top of itself. And so how do we get these guys to move?
Ooh, can we just pause real quick, Harry? Just to check in. There are a few questions and a few things I want to point out. If you just scroll up above your simulation, above the canvas there, you'll see I added a nice little range input that if you dynamically slide, it'll change the number of people in the simulation.
Whoa.
So this gives us a nice way of exposing different parameters and connecting them just to a variable. So down in the simulation, we're just going through the number of people, num people. And then we had one question in the chat about the spread operator. So if you go just upstairs above your class Simulitis, Maya Gans uses that upstairs downstairs, which I love. So just below.
Oh, shoot. Sorry, Mike, are you still there?
Oh,
I just missed you. Yeah, sorry. You said just below and then something.
Just below the D3 and random uniform.
Is this in comments?
So if you just scroll down, there's another cell below the D3 random uniform. Just a quick example of some destructuring. It is absolutely some new JavaScript wizardry of taking an array and sort of breaking it out, spreading it out into its constituent parts so that you can use them in, say, another array.
Exactly. Yep.
And I'll just go ahead and republish this. So if you now go back to this link, you'll see the notebook at this juncture. Now, Harry, keep going. Thanks for pausing, for letting us catch our breath.
Okay, cool. Yeah, and I see something in there about, I don't know, Ananya, if there's a way to draw a flat dot instead of a circle. There might be. And yeah, I mean, I'm avoiding using SVG because Canvas is going to just be faster. SVG, like every circle is going to be a node on the DOM. And after you get a certain number of nodes, it kind of slows it down. And it's not like Canvas is, it's not like WebGL or something, but it's a bit faster. Okay, so
oh, did we maybe lose Harry, or am I lost? Is Harry frozen for people, or am I frozen for people? We lost Harry. Okay. Well, we'll have to wait to get him back. Lord knows I can't carry this forwards from here. So, whoa, now we totally lost Harry. I imagine he will be back in the stream shortly, probably just getting his internet connection taken care of. And I see him.
Oh my gosh.
And you're back.
I'm sorry about that. I don't know what's up with my internet, but hopefully that won't happen again.
No problem. We'll just need you to reshare your screen here, and we'll keep going.
Okay, cool.
I did get very nervous, though. I obviously couldn't finish the simulation myself.
All right, let's do this thing. Okay, so on each tick, what is going to happen? We're going to loop through the people. So we can say like this each. And let's think about this. So, yeah, so we're going to say person, and then we also get the person index, which we might use later. In fact, we will use later. And so we're going to have a function. Okay, so for each person, we need to update their position based on their current speed and their current angle. And so for this, we are going to use a library that I made called Geometric. And Geometric, it's a JavaScript library that is this working? I can't tell if my internet's any good.
I can hear you.
Okay, good. Yeah, so it's this JavaScript library. It just has like a bunch of functions for like doing geometry in JavaScript, two-dimensional geometry in a plane. So yeah, so you can see it's kind of like a small library. I don't know why it's not. Let's require.
Oh, interesting. I'm getting it just fine. You might just have to reload your notebook if your internet's a bit slow.
Okay, yeah, we got it.
There we go.
Cool. Okay, awesome. So we're gonna, in this each function, we're gonna update the position of every person based on their current angle and speed. So this, or sorry, not this, person.position equals, and there's this function called geometric point translate. Also, do I need to switch over next, or?
Yes. I was wondering why I wasn't seeing your updates.
Sorry about that. Okay.
Yeah. So Harry just switched over to our sort of our beta version called Observable Next that anyone can switch over to, and that is what is enabling this live collaboration where we can see each other's icons.
Yeah. Okay. So geometric point translate, and point translate, we can just look it up. Point translate, it takes a point, an angle, and a distance. And then it moves the current point by that angle and that distance. So we're going to take the current position. And then again, angle is the second argument. So the person's angle. And then the distance is going to be their speed. Right, so that you move less distance on each tick if your speed is slower. And yeah, let's see. Hang on. Person position. Well, geometric point translate, person angle, person speed. Just trying to figure out why that's not working.
Have we actually ticked? Are we ticking?
We're not ticking. Good call, Mike. Yeah, so while true, yeah, simulation tick. Whew. Okay, so now they're just gonna disappear, right? So all the people just move off of the screen. So how do we get them to stay in the box? So what we're gonna do is we're gonna use a function from geometric called angle reflect. And angle reflect takes an angle of incidence and a surface angle, and it just reflects the angle off of the surface. So we need to detect when each person makes contact with one of these surfaces, the left side, the right side, the top, or the bottom, and then reflect their angle when they do. So we can think about it like we can say X and Y equals person position. So that's going to be the the first item in the position array is going to be X, and the second item in the position array is going to be Y. And we can say if X is less than, what would that be? Or we could say, if X is less than the person's radius, that's going to be on the left wall. So we can say person angle is going to equal geometric angle reflect the current angle and 90, because it's a 90-degree angle on the left wall. And let's just do that for now and see what happens when they hit the left wall. So you see over here on the left wall, they're just bouncing right off of it.
The magic of geometry.
Yeah. So, oh, you know what we should do too? We should make a restart button.
Ooh, restart button.
So I think it's inputs.button. I think this is like insanely simple. Yeah. And I think we could just put it right here. That'll be fine.
Yeah. So every time that restart changes, that cell will reevaluate, which means we'll be able to restart the simulation.
Yeah.
That's a great trick.
Yeah, it's cool. Okay, so let's do this for the other three walls. So actually, the resulting angle is going to be the same if it bounces off the right wall. So this is going to be if x is greater than, let's make it or equal to. So if x is greater than or equal to the width minus the person's radius, that'll be the right wall. Forgetting. And so now they can only escape from the top and the bottom. So coming back down here, now we're going to say if y is less than radius, or if y is greater than or equal to the height minus the radius. And we're going to do a reflection, a geometric angle reflect off of a 0 angle, surface angle. And that should work. So yeah. Now they're just bouncing away.
Amazing.
Okay.
If anyone's impatient, we now have the speed slider just above there too, which if you really want these folks to move around, you can speed them up.
Yeah, cool. That's awesome. All right, so now the hard part. We got to get them to bounce off of each other.
Now the hard part.
Yeah, so this one, I mean, this took me sort of a while to think about how to do. There are better ways to do what I'm about to do. I know that. And what we're going to do is not like the physically accurate way of doing it, because they're not going to like transfer forces or anything like that. But since all their speeds are the same and all of their radii are pretty small, you're not really going to be able to tell that it's wrong. But if somebody wants to fork this notebook later and implement the correct collision detection, result, I would welcome that. But so here's what we're going to do. This is just how I did it. So that's how we're going to do it now. So the way that I think about this is if you have two circles just moving randomly, you can compare them to each other. And specifically, you can compare the distance between their centers and the sum of their radii, right? So if the distance between their centers is less than the sum of their radii, that means that they're on top of each other, right? Or that they've collided. And so what we're going to do is when they do collide, we're just going to swap their angles and speeds. And again, with the caveat that that is not what happens in like reality. So like one thing that's a problem is they won't glance off of each other correctly. So if they kind of collide like this, you'd sort of expect them to move off like that, but they're just going to go like that. But it won't really matter. So yeah, so let's do this. Now we're going to make a second loop. So we have, again, we're going to run this each. This time we're going to say target and target index. And we're going to wait. We're going to do it like this. And so the first thing that we want to test for is if the person index and the target index are the same, then that means that it's actually just the same dot. And so we don't want to compare those to each other. So we're just going to say if person how about, yeah, if person index does not equal target index, and we can go ahead. So the first thing that we want to do is we want to compute their distance from each other. And so to do that, we have another function from geometric called line length. Because you can think that the distance between 2 points, the center of 2 points, is just the length of the line segment that is like starts and ends at their 2 points. So we're going to make measure the length of the line created by their 2 positions.
Are you also surprised, Harry, how much your adult job involves like middle and high school geometry? It shocks me on a daily basis how much I try and do things like this.
It just makes me wish I'd paid more attention in math class.
Yeah, if there are any middle or high school students spending their Sunday afternoon watching this stream, take that advice from us. Pay attention in your math classes.
Yeah, I mean, I actually started taking math classes as an adult in community college because I realized how useful it was for my job. But man, if I had just paid more attention when I was younger, instead of like, you know, driving around in cars with my friends, I probably wouldn't have to take those classes now. So anyway, yeah. So what are we doing here? If the distance is less than the radii, for the time being, we're gonna have to change this a little bit later, or make it a little bit more sophisticated. But for the time being, we're just going to say if the distance between the 2 points is less than the radii, that means that they've collided. And so we're just going to swap their angles and speeds. So the first thing that we need to do is person, let's see, person angle. And that's going to be their angle. We don't need to swap their speeds because all the speeds are the same. But I like to imagine that somebody could use this function in another notebook and have different speeds. So we're just going to account for that in the code, that maybe they'll have different speeds. And yeah, and then so we can say target angle equals the person angle, target speed equals the person speed, and then person, wait a minute, am I doing this backwards? Yeah, I did it backwards. So the person angle is going to be the target angle, and the person speed is going to be the target dot speed. Now that has changed, but we still have the previous angle and speed that we can assign to the target. Person angle, target speed equals person speed. Yes. See what happens.
Is that it?
Well, they're bouncing off of each other, but you'll notice that some things are not really doing what we want them to. The big problem here is that they're getting stuck to each other. And so we don't want that. And like some of them are kind of getting stuck outside of the thing. Basically, when they get stuck to each other, it's just like they've overlapped too far and they never escape each other.
This had to have just been a heartbreaking moment to see. Like you had done the 99% of the work and it looks so good. And then there's just like, why are you sticking together? This is horrible.
Yeah. So I had to really reason it through. And actually later I was like emailing with a professor of mathematics who assigns his students like something like this as like one of the first assignments. And one of the big sticking points is always that they get stuck together. So it's a pretty common issue.
It's one of the big sticking points, really? Really?
No pun intended. So the way that I figured this out, and again, like maybe not the most computationally efficient way to do it, but is basically that we can sort of measure what their distance from each other would be if they swap angles and speeds. And if that distance after them swapping is closer than it was before, then we're just going to not do the swap, right? and we'll just let them keep moving. But if after swapping they're farther away from each other than they were before, then we're going to say like, okay, that's a good swap. We'll just let them do it.
Ooh, I do just want to try out this suggestion from Hell on Earth that we can maybe swap these just by using some destructuring.
Ooh.
Let's see if that works, right? If we, well, maybe let's just try the angle first.
Wait. Swapping, I think you could use.
Yeah. If you scroll down into the into right there, this is awesome.
Wait, I didn't realize that works.
It's incredible.
What?
And so dense to read.
Holy shnikes.
Yeah, that's wild. Wow.
My brain is like breaking.
The way that object assignment happens in the same, yeah, that's wild.
Whoa. Okay. I'll take it. Sweet. Yeah. So let's except you know what? I think that we're probably not going to end up using this. We might, but so. Yeah, I think we might not want to do it this way. Just because we're going to need to measure what the distance would be if they swapped. And we're going to need to do that before this if. Or actually, no, I guess we'll do it within the. Okay, so let me just sort of think this through, and then if we want to use that, we will.
Yeah, there we go. We should be back to where we started.
Okay. That works.
Okay. Ooh, what did we screw up?
Are we good?
I see an unexpected token. Where did we? By we, I obviously me.
I don't know. There's probably like a hanging bracket somewhere.
Was there maybe like a copy and paste? I see the code twice. Did that do it?
I don't know. I could switch it. I could switch it. Oh, you got it? It's gone?
I think we got it.
Okay, cool. All right. So let's try to power through here. Yeah. So I'm just thinking, okay. So if the distance is less than or equal to the radii, yeah, so I'm going to do a couple things here. The first thing is actually I'm just going to say, okay, person position equals geometric point translate. Person position person. So this is like where they would be if they just kept moving, which we're actually doing also down below, but anyway, it's fine. Target position. This is where the target would be if it kept moving. So target position, target angle, target speed. And then that would just be like their distance. We already have a something called distance, new distance, which is geometric line length, person position, target position. Okay, and then we want to measure the swap. Okay, measure the swap distance.
How you start commenting the code?
I just did it. It's crazy. Okay, so person position swapped. And so this one is like, what would happen if we swap their angles and speeds? So we sort of have to like test it before it actually happens. Person position using the target angle, target speed. And target position swapped. This is what would happen if So if the target position uses the person angle and the person speed, and then we have a swapped distance, where we're going to do geometric line length, person position swapped, target position swapped. Now, if the swapped distance is greater than the new distance, that's a real collision. And so, yeah, I guess then we can actually do that thing.
We can actually do that thing.
Yeah. And so I'm sure that there's like better ways we can do this, but for the time being.
Yeah, what I appreciate about this, even though it does take a couple of steps, is that your sort of mental model or description of what should happen translates pretty explicitly to the code, right? You're saying, well, if we were to swap them and they were still too close, like let's make this different choice, right? Like you're actually taking those steps in the code.
Yeah, right. Yeah. So again, I welcome forks and improvements. But as you can see, it's working now. So they're not getting stuck together, and all is well. So now the last thing that we need to do is to make them sick or healthy. And so what we're going to do is, you know what? There's one more thing that I want to do here actually in this, which is I'm going to add a property to each object called HasCollided. I think this makes sense, just so that they don't like collide twice. Target HasCollided equals true. Then up here, we can just check and not person has collided and not target has collided. And then on each tick, we are going to say person has collided equals false. And I don't know, I could just in my mind that makes sense that we don't want them to collide more than once on each tick. And I don't know if it makes a difference, but it's still working, so that's good. So yeah, let's make them sick. So we are going to in our default like description of people, we're going to give them a state. And the default state is going to be healthy. Which is a good default state for people to have. And yeah, then when we're adding them to the simulation, we can set their state. And basically, we want to say if, let's make the first one sick. If I equals 0, he's going to be sick. Otherwise, they're going to be healthy. And yeah, so the only way that we, the viewer, can know who's sick and who's healthy is through color. I mean, we could, I guess, change their, oops, what did I do? Right, why would I put a semicolon there? Yeah, so I mean, you could like change their shape, I suppose, or something like that, but color is a pretty good way to encode these. And yeah, so for color, like in the Washington Post, I used like the Washington Post's color scheme. I think the main thing is that we just want to avoid like issues where people who are, have color blindness won't be able to tell the difference between the colors. I like to use Color Brewer. If I'm just like, want to pick some colors that'll be good. This is qualitative data. And yeah, so we can use this scheme, which I know it comes with D3 now, but I can't remember what it is. And this is okay. This is good enough. So yeah, I mean, I have this like color blinding checker on my computer. It's kind of a nice little thing. Yeah, tritanopia. I wish I knew how common all of these were, but I often use this for picking colors. And so for this one, I think we'll make healthy like this guy. So let's make some colors here. Colors, gonna be object. Healthy is going to be that one. Sick, we want it to be like a dark red, so it kind of jumps out. And then immune we're going to have too. And we'll make it like this one, the blue one, but we'll make it just a little bit darker. So D3 has this D3 color, and you can just say darken, I think. Is it darken or darker?
Let's find out.
Darker. And you can say like 0.2 or something. I think that works if I say like colors.immune. Yeah. So it'll just be like slightly darker, which you'll see will be useful. So yeah, so what are we doing here? We want to color our circles. And so the way that we do that is context fill style equals colors person state. They are all healthy except for that one dude who's sick. And yeah, so we now know when they've collided, right, down in our code. And so now all we have to do is when they collide, if one of them is healthy and one of them is sick, we're just going to make the healthy one sick. So that's happening down here. So yeah, so if person state equals sick and target state equals healthy, target state is going to be sick. If let's do else if target state equals sick and person state equals healthy, person state is going to be sick. So there it goes. It is spreading through the simulation there. And then
that's such a moment, right? When they actually collide and now they're changing colors.
Yeah, I know, it's great, right? And let's see. So, I mean, the nice thing about doing the darker one for sick is that anybody can see, even if they can't see colors at all.
Can you tell us what that color blindness checker is?
It's called Spectrum. It's kind of neat. Yeah, I recommend it. There are lots of them, though. I think you can just, if you're using Google Chrome, you can just look for extensions for colorblind checking. And then there are ones that like will make your whole desktop like change for colors if you're using like Adobe Illustrator or something like that, and you want to see if it's colorblind friendly. The last thing that we need to do, because we're running out of time, I see. So really quickly, we need to make it so that they can become immune. We need to make it so that they can recover. And so the last thing that we're going to do is we're going to check this tick on which they became sick. So if I equals 0, you know, he became sick on the first tick. Otherwise, we'll just do null because they haven't become sick yet. And then, yeah, I guess we can make yes, a property here called ticks, which is going to be 0. And then on each tick, we are going to increment that. Maybe after the tick is over. So down here, I'll say this ticks ++. Oh, yeah, you got it. Nice. And then, so we also want a property called, let's say, I don't know, sickness ticks. And we'll let that be configurable. Sickness ticks. Sickness ticks. Otherwise, we'll just make it like 500. Oh, not ops, options. Okay, and so when somebody gets sick, we are going to track the tick that they became sick on. So we're going to say target sick tick equals this ticks. A person sick tick equals ticks. And then the last thing that we need to do is on like the very beginning of this each. Let me think. Should it be here? Yes. It should be here. Yeah. So we want to say if the person's state is sick and this ticks minus person sick tick is greater than the number of ticks that we let each person be sick for, we're going to make them immune. That should just handle everything that we need. Let's just wait. We have to wait like 500 ticks here. See if
we can turn up the speed.
Oh yeah. Oh wait, but you see this dude? So they're becoming immune. Awesome. So I think that's all we have time for right now. The next things that you would need to do if you really wanted to build this out is to keep track of the state of the simulation over time. So on each tick, how many people are sick, how many are immune, how many are healthy. And then using that information, you can make these like, stack area charts or whatever kind of visualization that you want to show like how the simulation has changed over time. And then if you wanted to really do it like it is in the article, you could add like quarantine walls and build in some logic for that. You can make it so that some of them can stay still. And if, this is a different type of collision, because if it's still and a moving one hits it, you don't want them to swap angles and speeds. You just want the still one to stay still. So so there's ways that you can improve this. But I think for now, since we're out of time, that's all we got. But I can stick around and answer questions and stuff. I'm happy. I don't have anything to do. So if you guys can stick around, I can stick around too.
Yeah, well, I'm definitely here for some questions at exactly 1 hour that came through, which is
I wasn't sure we can make it.
And I think I love how you took something that when I glanced at it at first was so complex and there's so many different components to how it worked. And you solve them one at a time, right? You started with a box, you put dots in the box, you made the dots move, you kept them in the box, you made them bounce off of each other. And I think that was it's a great example of taking a complex problem and breaking it into its constituent parts to get to something that's really amazing, which we're getting a lot of accolades for here in the chat.
Cool. I'm glad you guys liked it. And I think it does show that like you don't need to have any kind of well, I want to couch this correctly. I was about to say you don't need to have any subject matter expertise to make something like this, and like that's not true. In the article itself, like I interviewed epidemiologists and things, and something that I do as a journalist is I'll try to schedule like a video call with people I'm interviewing, and I'll show the expert the graphic that I'm working on and ask them like, so how is this bad? How would you improve it? How am I misleading people? And have them weigh in. And use their expertise to kind of make the graphic better. But I think that what this does show is that like you don't need to be a physicist or like a computer scientist to be able to sort of think your way through a problem like this and make something that's sort of effective and works well enough.
Absolutely. Absolutely. Well, if there aren't any questions in the chat, going once.
Let me see. I have something from C Basis. Would it be an idea to fill the circles in white, black outer line? How should I set context fill to get it? I'm not sure I totally understand the question.
Yeah, I think like if we wanted circles that only had a stroke on the outside,
Oh
until, you could
I-
maybe
pretty sure
augment the context dot stroke.
Boom. Yeah, I mean, I sort of like the filled version. I think it's easier to track with your eye, but you can do it that way if you want.
Awesome. Well, Harry, this was amazing. Is there somewhere that people should go to see more of your work? Should they go to your, we've got this link on the Washington Post. Is there a better way to keep up with what you're doing?
Yeah, I guess. I mean, I have a Twitter, although I have to admit I'm kind of trying to use it less.
Are
But
you
that's
succeeding?
well, what I did was I just unfollowed everybody, which was a hard decision to make because I had carefully curated the people that I follow over many years, but it was just that they were too interesting for me, and I just didn't have the self-discipline to say I'm going to use Twitter less. So I tried unfollowing people, and if I want to go back, I'll follow them all again. Anyway, it's twitter.com/Harry_Stevens.
There we go. But if you follow him, do not expect to follow back. At
least not for now.
At least not for now.
I might get back into it and start following people again, but I'm just trying to use Twitter a little bit less.
Yeah. One question. What was the museum website? I'm not sure what that is referring to.
Yeah, Sunola. Could you elaborate? I don't recall. There was a Washington Post article where they did a 3D museum exhibit, which might be what this is referring to, but I didn't work on that. But it's pretty cool. It's got a T-Rex in 3D. Check it out.
Nice. Will do. Well, Harry, this was just an absolute pleasure to walk through this. I've got a link up for our future meetups. And I think we can kind of close out with that.
Awesome. Well, this was really fun. Thanks everybody for joining. Then thanks, Mike, for hosting this. This was really great.
Yeah.
And Ananya too. I really appreciate it.
Awesome. And thank you, Harry. We'll see you around.
All right.
All right.
See y'all.
Take care, everybody.